I'm very glad and thankful for having me. And now you can see my Zoom, and I need to get it to present itself here. Do you see my working
yes.
desktop for Zoom?
Yes, we see your PowerPoint window.
Yes, but I need to get it to
presentation mode.
Yes, because when it's in presentation mode, I don't see Zoom anymore. Which I find suboptimal. Maybe we just go with the.
Yeah, that's fine.
Yeah, I try to make it bigger. Ooh, that was a little too big. Okay, thank you very much. My name is Cornelia Schindelin. I work at one of two universities, and I work in teacher training or translator training. But I do have my hobbies and inclinations, and one of them is Japanese writing system. So I'm trying to present today something that I did. I will explain just a little bit, and I try to hurry and still articulate clearly. Maybe that will work. What I did is I took Köhler's basic model of synergetic linguistics. Mr. Köhler is Reinhard Köhler, a professor of quantitative linguistics who is retired by now. And he let his students use his model and adapt it to their purposes and research questions and kind of play around with it. And so I will introduce this model very quickly and say some words about the data that I used. And then we shall look at the 6 hypotheses that I tested. And we try to talk about how things came out. So Reinhard Köhler developed this model, which he called a model for synergetic linguistics, which is the attempt to integrate into one model various relationships or dependencies between various factors of, what do you call that in English? Entities, linguistic entities that can be quantified, which the relationships between which were already known and had been explored before, but they had not been integrated. And I try to make this illustration here a little bit informative so I don't have to talk about all the details. We will mainly be concerned with, where is it? A certain part of the model, this one. And the rest will come from the corpus. So the corpus that I got my data from and the characters of which I used in simplified form was the Frequency Dictionary of the Modern Chinese Language, which appeared in Beijing in 1986 or was published in Beijing in 1986, consisting of texts from various genres. And it is viewed from today, it was moderate in size. It is moderate in size, but at that time it was considered quite big and has nearly, yes?
We are still seeing the first slide only.
Oh, that is very strange. Okay, I will go back then. What do you see now?
The title.
Icon.
Now we see Frequency Dictionary.
Okay, then there is a certain inertia in there.
We see slide 4.
Okay, I had gone back to slide 3. Maybe I'll open my PDF. Or one of my PDFs will not be as pretty as the one that I just had open. I'm sorry. I need to share again. Okay, that's not let's not get nervous.
No need.
No, that's not the one I wanted to open. Okay, the correct file is open now, and I think we shall be able to proceed in a moment when I share it again. Here's my Zoom. Everything is good as long as I do not close Zoom by accident. This must be it. Okay. So this was the model I was talking about. Or this is the model I was talking about. Can you see my cursor anyway?
Yes.
Yes, okay, very good. We will be mainly concerned about the left part, which I'm trying to circle right now, as there are quantities taken from the corpus here. Inventory size and number of graphemes once you have a corpus is given, but you can explore the dependencies that seem to hold within this corpus between frequency, graphical complexity, functional complexity, which is the number of different words in this case the character is used in or for in the corpus, as this these data could be culled from the lexicon, the frequency dictionary, which one thing I could not get from the frequency dictionary is the number of texts of individual texts a character would occur in. And at the end, functional complexity and frequency. So we will see this again. We know the number of characters and of component graphemes for which I am indebted to Hartmut Bohn. And well, let's get going to see what is happening between these three rectangles. This is the slide you stared at for a while. I'm sorry for that. The frequency dictionary was put together in the early 80s. So when you go back in your mind in that time, you can be sure that all the texts in this corpus were certainly handwritten at the outset of their existence, because the tools we have at our fingertips these days were not existent at that time. If anyone wants to download slides, it is possible from the program page that Yannis has provided. So the characters appear in more or fewer words and in different positions. I'm not going to go into this here because I want to get to the hypotheses. And there were three direct hypotheses because there were three direct dependencies that had been explored before. And actually, I have to insert one sentence here. Köhler had intended this model to be quite general, so it could be applied at different levels of linguistic analysis. And he and several of his students had applied it to the vocabularies of languages as found in text corpora, of course, Western languages written in Latin letters, Roman letters mainly, and had published their observations and their results. And I took it for the Chinese character or writing system, not because I think that characters are something like lexical items like words, but because I think that Chinese characters do have some characteristics that are comparable to characteristics of words, as in they have lengths, they have different uses that we can count and classify and then count the classes and things. So they the same needs for coding and decoding and minimizing the inventory and the other needs that are represented here in these oval things also work on the characters. So I wanted to try to find out how the model would behave in regard to Chinese characters. It's very briefly the background. So the first hypothesis, before I get to that, there were three indirect hypotheses, that is hypotheses. And that's really where we get to try to find out if the model is promising, whether it can preview, no, that's a different word, can get you to, I'm losing the word here right now, whether mediated dependencies, indirect dependencies are also modeled correctly, that are those arrows here, colored arrows that go through another rectangle, stating, for instance, that functional complexity is indirectly dependent on the frequency, on average, of Chinese characters mediated by their graphical complexity. And we will hear a little more about graphical complexity. The first hypothesis is quite straightforward, that functional complexity is directly a function of graphical complexity, and we had some examples of this phenomenon 2 days ago. The model is suited for logarithmized equations, but there is always a corresponding power function, and I give both. So what I did regression on the data points, a linear regression to get estimations of the parameters, and then I recalculated them for the power function. The graphical complexity was measured in 3 ways. That is number of strokes, number of component graphemes, here shortened to graphemes, and something I call writing effort here in English. Supposing that a stroke that makes a change of direction takes more effort to write than a simple straight one. So all the strokes are weighted, and I got the data from Hartmut Bohn once more. And in all 3 cases, regression was very successful. That was, the determination coefficient of D being above 9, even above 0.9, And so the curves also look very good in relation to the data points. So I went on to the text frequency of Chinese characters being a function of the functional complexity. The functional complexity, again, being the number of words a character is used in or for, different word types in or for in the corpus. That is this part of the system. And the determination coefficient was very good again. Naturally, the data scatters a little more around the curves. Still, the regression was very successful. For practical reasons, the data points had to be weighed, and maybe we do not discuss the statistical fine points here for reason of time. The third hypothesis was that graphical complexity of Chinese characters is a function of their text frequency, which is sort of a way to say characters that appear more frequently in text probably are shorter, have lesser strokes, lesser components, or simpler components. And if you know the Menzerat-Altman law, maybe that rings a bell. As complexity is measured in 3 ways, we again have a bunch of data. I also had to class for frequency to make the data feasible for regression. And I have class kind of frequency windows of 100 and of 50 from the frequency data. And so we have a bunch of results, but the goodness of fit was very good in each case. And here we see again the curves, the 6 curves that resulted in the data points scattering around them, but as I said, with satisfactory goodness of fit. Now let's get to the first indirect hypothesis, which is the graphical complexity is indirectly a function of functional complexity mediated by frequency. And we get the equations by inserting what we already have found out from the direct dependencies. And because of the different measurements, we get a bunch of equations that were all tested against the data to see if the model would predict, that's the word, predict accurately the equation of the indirect hypothesis. This is the raw data, and the regression fit for this dependency. And now let's look, or maybe look at the numbers, but look at the curves here in the power function form. And you see that there is a little distance between the fitted function that was fitted to the data and the predicted function. The distance is very small in one case and a little bigger and quite bigger in the other case. We need to look at the correlation determination coefficient, and it was not very good, which is not surprising anymore, having looked at the curves already. It was 0.7, 0.6. That's not very good. So not satisfactory. So this hypothesis needs to be, it cannot be accepted. It needs, at this moment, it needed to be rejected. And I'm still not accepting it. The fifth hypothesis does the same for functional complexity being dependent from frequency, mediated by graphical complexity. And we do the inserting stuff to get the equations. The fit to the data, to the empirical data, was satisfactory. Regression was very good. Even though you see data point scattering below the curve, mathematically, statistically, it was very good. Oh, yeah, the PDF is not as good as the PowerPoint. But when we look at the curves as predicted by the theoretical functions, we see the fitted curve taking off to the top right corner, while the theoretical functions get asymptotic very quickly. So that does look pretty bad, and we need to reject this hypothesis because the fit is the prediction is not good enough. Maybe there's something in the model, or there's something lacking from the model, Köhler's model, that is causing this to happen. The last hypothesis was on text frequency being indirectly dependent on graphical complexity. And we did the same thing. The regression results on the actual data was very good again. So there seems to be something there. And the curves, you can see from the curves, because of number of data points in certain regions, some points are below the curves. But when we compare with the theoretical functions, the predictions from the theoretical function, we again see that the curves are not very overlapping in some places, especially where the number of strokes or component graphemes or the writing effort is very low. So, any conclusions? Well, statistically, the three direct hypotheses could be accepted as regression was very good. But there are problems with 3 indirect hypotheses. I didn't talk about testing. The testing was like not very sophisticated. I did just the same kinds of tests that Köhler had done on his in his studies, which is basically t-testing. And there are problems with that have been discussed in the literature also. The last hypothesis withstood testing. It was good enough to pass the test, but H4 and H5 could not be validated on the data, which is not a very good formulation, but there seems to be some systematic deviation, maybe a factor involved that needs to be yet considered. Maybe they can be evaluated as a step in the right direction. Overall, I have to say, looking back at the studies done on vocabularies, they had similar problems. They had the same hypothesis show to be problematic and not have very good prediction, which is another point to say. There are certain places that this model needs to be improved upon to be better in predicting dependencies that are hypothesized. So insofar as the model did not behave dramatically differently from those models that were, or those versions of the model that were tested on vocabularies or words, I'm very satisfied with what came out of this little endeavor. So thank you for listening. And my last word is that I am indebted to Professor Dr. Reinhard Köhler for letting us play with this model, to Dr. Hartmut Bohn for sharing his grapheme component analysis and his stroke weighting data with me. And last but not least, to Yannis Haralambous for having this presentation at this conference. Thank you very much. And there's some literature if anyone is interested.
Thank you, Cornelia. Any questions? I have a question. So you're talking about writing effort, but writing effort depends on the support and the media. Would this writing effort be the same if it's a pencil or a pen or a brush?
It would be different, but we would suppose that the same text, or that either in the every individual text would be written on the same medium. I mean, we are talking about a corpus of texts that have been published. So when the people who put together the frequency dictionary did what they did, they took the published versions of the text which had been put into, I think, lead print at that time. But before any text would go into the publishing house, it would have been written down, ink on, that is a fountain pen on paper, or Qianbi, pencil on paper, less likely by a brush. Brushes are used for decorative purposes, for art purposes, but nowadays hardly to write a work of prose about some political thing that is relevant in the time of publishing. I mean, these texts, some of these texts that are prose texts, the prose text part are not texts that we would want to read today. Things certainly being different for the fictional part of the corpus. The corpus was intended to reflect what an averagely educated Chinese would read during his education and his lifetime, as for leisure, for work purposes, and certainly for the Department of Political Education that is indispensable in mainland China. So I think, yes, effort would probably be different also for different people. But texts are longer things of writing, so that kind of would, in my view, at least even it out among individual characters. It's not like the first character is very hard to write because it's written with the fountain pen, and then you change to a badly sharpened pencil and write the next character. So the writing effort is very different. It's not like that. So there is some kind of averaging here, but I think it's fair to accept that.
Which brings me to the next natural question. More and more people use input methods on keyboards. Are you ready to formulate an hypothesis for input methods?
Not yet. The input methods that people use vary by what they are used to, what input method they have studied. Like I just type pinyin. Other people have the system where you just type 2 letters to put together a pinyin syllable, but you have to learn which 2 letters belong to the initial and final of what syllable. And from what I hear from people who use mobile devices is that just swiping your finger on the touch screen is very popular. So we would first need to find out what kind of input methods are used by whom and for what kinds of texts, and how would that make up a corpus that is representative of something. So I haven't really thought very deeply about that. I was just glad, as I thought about the frequency dictionary, that I can quite safely say that all the texts in that corpus must have been written by hand at that time, before to be written into existence. But sorry, no, for all these input methods that are around today, I have not yet arrived at any conclusions about what writing effort would mean in that direction.
Okay, we have a question by Chen Sheng Song.
Hi, I'm here. Thank you very much for this wonderful talk. I enjoyed it a lot. My question is actually also on the point of writing effort, but from a slightly different angle. And I was quite curious. So when you were measuring the writing effort factor or that parameter, did you take into account, say, the variation between different handwriting styles or scripts? For example, the difference between the regular scripts that we see in print and the more cursive ones that people actually use in our real life. Because in my personal experience, I think even though some strokes look very difficult and complex to write in a regular script, they become much easier in reality because we don't write a full form, we use shorthand forms. So did you take into account, or to what extent might that be relevant?
That is a very good question. And indeed, I did try to take that into account fairly without having been able to look at the original manuscripts, of course, of these texts. And if that's okay, I would just say how Hartmut did the weighting stuff for the strokes. He really just weighted the strokes by their changes of direction. While someone could also argue that depending on where in the character component appears, the length of the strokes also varies. But that would make it very difficult to
yes,
kind of count kilometers or miles or something, count the mileage of the ink. That would be also kind of ridiculous. So he kind of argued that the motorics or the kinetics of writing strokes changing direction are bigger than just writing something straight. So that is how the weightings of the strokes came about. Changes, number of changes of direction. And as for handwriting or Xingshu writing, or the handwriting that people like you use since you had to jot down notes in university, I took a textbook that is written by at least one Chinese person and is intended to introduce you to Xingshu. It's a very good textbook, and it's not very new. It's kind of old, but I used it to compare the Kaishu print typeface with the handwriting, and I took a sample of characters, but I'm sorry, I don't remember how big the sample was, and compared the number of strokes. And of course, you need a kind of rule what counts as a stroke in the Xingshu form. And while it is easy to say what counts as a stroke in the Kaishu form, the printed form. And I made it, I looked at the distribution of the differences between the two types of writing and found that the difference was not very big.
Okay, interesting.
I didn't test that statistically, but the difference was small enough to say that I can take the data from the frequency dictionary and get some results that are worth talking about, because it's similar.
So that means even if we only focus on say the printed form, the Kaishu, the results we get are still informative enough that we can make the same predictions, more or less the same predictions about handwriting scripts.
Yes, absolutely. I would argue in this direction, and especially for simplified characters, I would argue in this direction, because we are aware, of course, that simplification was not a random or process on the whim of somebody who's pretty crazy, but that many characters that were simplified actually got into the simplified character set because a handwriting form that had been popular and used everywhere before was now raised to the prestigious level of the correct orthography. So, and there are many components that if you would want to shorten them or abbreviate them further, they would become indistinguishable. So actually the simplified characters, even though you can still in some places by just not picking up the pen from the paper when you make the next stroke and stuff, change their appearance, they are very, very close to what people actually had been doing for hundreds of years in their handwriting.
Okay, I see. That's very good to know. Thank you very much for the answer.
You're welcome.
And a last question from the audience.
Hi, Pierre Magistri speaking. Thank you for this very insightful talk. Just a short follow-up on this question and discussion. I would expect that just as you said, the simplified form very often existed before simplification. And so I would be very curious to see the same computation on traditional Chinese. And I would be curious to see if the most different character between unwritten script and Kaishu wouldn't be your outliers.
I didn't understand the last word, I'm sorry.
Would be outliers in your computation.
Outliers.
At that point.
Yeah, that's an interesting question, which will need some follow-up work to do. I had hoped I would be able to do a similar thing for the unabbreviated characters like used in Taiwan, but well, my my work kind of got me away from this path, following this path, and it would have been easier to do if I had gotten the same type of data readily to evaluate to do this. But as this was not the case, I had to put it aside and did something else in the meantime. But if you feel like doing it, you're welcome. I'm ready to discuss with you and show you what it was like and what we had been doing, or what I had been doing. And if you want to do it, you're very welcome. Right now I don't see, for myself, I don't see the time of doing it in the near future.
Okay, maybe we just need to complete the decomposition database with traditional characters.
Well, you need the corpus data. You need, it's not the same thing if you just take the characters from this corpus and convert them into Fanti Zi. It would not be the same corpus anymore. Because it would be different people having written it. Although if you now say, well, if in that corpus, maybe you have texts by Badin and other early May 4th authors that first were published in Fanti Zi, they were probably also handwritten in Fanti Zi, then maybe they should be treated differently. And then I would agree with that. We would have to look more closely at the corpus, but I would insist that you take a corpus that was originally written in Fanti Zi, completely originally written by people who have Fanti Zi, that is the traditional full form characters like written in Taiwan, as their first writing system, and take their texts and get the data for their components. There must be more components because Fu Yonghe found 648 different components in the big encyclopedia Zihai, and Hartmut Bohn found 499. So for Fanti Zi, we would also have to take different component data, component graphing data. It's not, and we would have, of course, to count the weights again. It is a bit of work. It's not just converting the same characters in these lists that resulted from the evaluation and convert them into Fanti Zi and then go again. It would be a little more work, and that's being aware of this. I had to put it aside for the moment.
You're right. Thank you.
Thank you very much, Cornelia.
Thanks for having me, and have a good afternoon, everybody.
Okay.